Hello students, the question is 2-point charges minus 4 microcoulomb and 4 microcoulomb constituting an electric dipole are placed at minus 9,0,0 centimeter and 9,0,0 centimeter in a uniform electric field of strength 10 to the power 4 Newton per coulomb. The work done on the dipole in rotating it from equilibrium thrown 180 degrees. Option 1 14.4 millijoule, option 2 18.4 millijoule, option 3 12.4 millijoule, and option 4 16.4 millijoule. So the problem is based on the topic electric dipole and the work done in rotating an electric dipole. So the work done in rotating an electric dipole is given by the change in potential energy, and the change in potential energy is given by the final potential energy minus the initial potential energy. So the situation is something like this, that this is the initial location of the dipole. The minus q charge, which is minus 4 microcoulomb, is at minus 9,0,0, and the 4 microcoulomb charge is at the position of 9,0,0 position. So this is the initial state of the dipole. So the initial potential energy is given by the expression. We know that the potential energy of an electric dipole is given by the expression minus Pe cos theta, where P is the dipole moment, E is the electric field, and theta is the angle between the dipole and the electric field. So cos theta is the basically the cos of the angle between the dipole and the electric field. So initial potential energy is given by, this is given by minus Pe cos of 0, because initially the dipole is making an angle of 0 degree. This is the direction of the electric field, and it is making an angle of 0 degree in the first situation. Then the final potential energy when the dipole is rotated in such a manner that it rotates 180 degree. So when it rotates 180 degree, we can say that at the minus 9,0,0 there is now the 4 microcoulomb charge, and after this rotation the position 9,0,0 it is having the charge of minus 4 microcoulombs. So this is the situation after the rotation by 180 degree. So in this final state, the value of UF, that is the final potential energy value, is given by minus Pe cos of 180 degrees. Now cos 180 degrees minus 1. So this value becomes plus Pe, and we know that cos 0 is 1. So this value is minus Pe. Now the work done is given by the change in potential energy, which is the final potential energy minus the initial potential energy. So it is given by Pe minus of minus Pe, because Ui is minus Pe. So this value comes out to be 2 times Pe. Now putting the respective values here of P and E. So 2 times the value of P is given by, the formula of P is given by 2Qa, where it can also be written as Q times 2A, where 2A is the total length of the dipole. So in this way we can say that 2 times Q multiplied by the total distance of the dipole. The total distance of the dipole is given by the distance between the respective charges. So you can easily see from this figure that one position is minus 9,0,0, another position is 9,0,0. It means that the total length of the dipole is given by 18 centimeter. So 2A is 18 centimeters, and this is multiplied by E. The value of E is 10 raised to the power 4. So 2 times Q time 2 into Q into 2A, which is 18 centimeter, into 10 to the power 4. Now we have to convert this value of 18 centimeter into meter. So we have to multiply it by 10 to the power minus 2. And the value of Q is also given here. Q is given as 4 microcoulomb, which is 4 into 10 to the power minus 6 coulombs. This multiplied by 18 multiplied by 10 to the power minus 2. After converting it into meters, then this multiplied by 10 raised to the power 4. Now solving this, 2 into 4 into 18, this is 144 multiplied by 10 raised to the power minus 4, which we can write down as 14.4 joule, 14.4 into 10 to the power minus 3 joules, or we can say that this value is 14.4 millijoules. So option 1 is correct here. Option number 1 is correct here. तो यहाँ पे क्वेश्चन पूछा गया है जिसमें पूछा गया है कि वर्क डन कितना होगा डाइपोल को 180 डिग्री रोटेट कराने के लिए इक्विलिब्रियम पोजीशन से। इनिशियली दे रखा है कि उसके जो चार्जेस हैं -4 माइक्रोकूलम चार्ज -9,0,0 पे है और 4 माइक्रोकूलम चार्ज जो है 9,0,0 पोजीशन पे है। हमसे वर्क डन पूछा गया है उसको रोटेट कराने के प्रोसेस में। तो वर्क डन होता है चेंज इन पोटेंशियल एनर्जी विच इज इक्वल टू होता है फाइनल पोटेंशियल एनर्जी माइनस द इनिशियल पोटेंशियल एनर्जी। इनिशियल पोटेंशियल एनर्जी के लिए हमने जो पोटेंशियल एनर्जी का एक्सप्रेशन है -P cos थीटा, इसमें थीटा की वैल्यू को 0 पुट किया है क्योंकि एंगल जो है डाइपोल का और इलेक्ट्रिक फील्ड के बीच का वो है 0 डिग्रीज। cos 0 की वैल्यू 1 होती है, वो हमने यहाँ पुट की तो वैल्यू आई -Pe। इसी तरह फाइनल पोटेंशियल एनर्जी हमने निकाली -Pe cos 180। cos 180 -1 होता है, -1 माइनस माइनस प्लस यानी Pe हो जाएगा। फिर हमने वर्क डन निकाला, चेंज इन पोटेंशियल एनर्जी यूएफ माइनस यूआई, दोनों वैल्यूज पुट करी, यूएफ की Pe वैल्यू पुट करी, यूआई की -Pe वैल्यू पुट करी, तो इस तरह से हम देखते हैं 2Pe वर्क डन बराबर 2Pe आ जाता है। P यानी कि डायपोल मोमेंट जिसकी वैल्यू हम निकाल सकते हैं बाय दिस फॉर्मूला Q इंटू 2A यानी चार्ज मल्टीप्लाइड बाय डिस्टेंस बिटवीन चार्ज। और उसमें भी हमें ध्यान रखना है कि इसको हमें एसआई यूनिट में कन्वर्ट कर लेना है। इसका मतलब चार्ज को हमें माइक्रोकूलम से कूलम में कन्वर्ट कर लेना है 10⁻⁻6 से मल्टीप्लाई करके, और जो लेंथ है उसको हमें मीटर में कन्वर्ट कर लेना है। तो इस तरह से सॉल्व करके जो हमारा फाइनल रिजल्ट आता है वो आता है 14.4 मिली एम्पियर। सो ऑप्शन 1 इज करेक्ट हियर। So hope you understand the explanation. Thank you.